All right, let's go over the section 7.1 notes on interior and exterior angles of polygons. So first thing we need to do is define a polygon. So a polygon, basically it's a shape. So a polygon is a closed figure formed by 3 or more line segments called sides. So I'm going to give you a couple examples of not polygons. So these are not polygons. Polygons, they really are just shapes. But there are certain shapes that are not polygons, so they have to be formed by line segments. So a circle is not a polygon. Something that looks like that, not a polygon, because this is not a line. So basically anything that has a curve is not a polygon. This is not a polygon because it's not closed. So this made up of a bunch of line segments, not a polygon because it's not closed. So it needs to be made up of straight lines, so you can't have these curves, and they need to be closed. So these are all not polygons. No. Okay. All right, moving on. So the sum of the interior angles, so the angles on the inside of the polygon. The sum of the measures of the interior angles in any polygon can be determined by the number of triangles that can be drawn within it. So we need to complete the table below and look for a pattern. So most of this is already completed for you, as you can see. So first one, polygon. First polygon that we can make is a triangle that has 3 sides, of course. And obviously the number of triangles you can fit in there is 1. And we know that the sum of the angles is 180. So this we already know. Let's look at a quadrilateral. So quad means 4. So a quadrilateral has 4 sides. The number of triangles is 2 because if you make a diagonal right down the middle, we have 2 triangles. So the sum of the interior angles, since we have 2 triangles, sum of the interior angles is 180 times 2, which is 360. So that equals 180 times 2. A pentagon, so pent means 5. So a pentagon has 5 sides. You can make 3 triangles in there. If you draw lines from one of the angles to opposite angles like this, you can make 3 triangles. So the sum of the interior angles is 540, which is 180 times 3, because we've got 3 triangles. Hexagon has 6 sides. And again, if you start at one corner and you draw lines to opposite corners like that, so opposite angles, the number of sides, we've got 6. Number of triangles, you can make 1, 2, 3, 4 triangles out of that. Sum of the interior angles is 180 times 4 because we can make 4 triangles. Moving down, these we don't draw them because they're hard to draw. Feel free to try to draw these, but the more sides we get, the harder it becomes to draw. So a heptagon has 7 sides. And how do I know? How do we know that we did 5, that we can make 5 triangles? Well, I'm looking at a pattern here. So as the sides go up by 1, so 3, 4, 5, 6, 7, 8, 9, 10, the number of triangles also has been going up by 1. So if in a hexagon you have 4, and a heptagon you can have 5. So there's a pattern here. So triangle 3, if you subtract 2, you get 1. Subtract 2 from here. 4 minus 2 is 2. 5 minus 2 is 3, 6 minus 2 is 4, 7 minus 2 is 5. I would say that's a pretty good pattern, don't you think? So 8 minus 2, you're going to have 6 triangles. Going back here, sorry. 180 times 5 equals 900. 180 times 6 equals 1080. Subtract 2, you get 7. So I think you can see the pattern here. In this, actually, we're going to turn into a rule, this pattern. So in order to find the sides, if you know how many sides a shape has, you can find the interior angles by taking the side number, subtracting 2, and then multiplying that by 180. and that works every single time. So here is our formula for that. So if n represents the number of sides of a polygon, then the sum of the interior angles can be found using this formula. So n is the number of sides, so like we set up here, you subtract 2 from the number of sides, multiply by 180, that gets you the total sum of the interior angles. So we've got some examples here. So if we have what we call a 15-gon, there's no special name, you just say 15-gon. The interior angles equals 15 minus 2 times 180. So 15 minus 2 is, of course, 13 times 180, which equals 2340. If we have a 21-gon, you do the same thing. You just plug that into your formula. 21 minus 2 is 19 times 180 is 3,420. If you've got a 48-gon, you do 48 minus 2, which is 46 times 180, which equals 8,280. If you have a 36-gon, 36 minus 2 is 34, times 180 equals 6,120. So this is just a formula so that you use if you're given the number of sides in a polygon. So next thing we're going to define is a regular polygon. A regular polygon is a polygon in which all side measures are congruent. Therefore, all angle measures are congruent. So examples of a regular polygon would be an equilateral triangle, which we've talked about. If all sides are congruent, we know that it's also equiangular, that word that I love. So all the angles are the same. Another example of a regular polygon is a square. All sides are congruent. All angles are 90, which are congruent. A regular pentagon. Nope, that was not. Hang on, I think I can fix that. Well, I did my best with that. Let's pretend this is a regular pentagon. You know what? No, I don't like that. That's not great. Let's try that one more time. 1, 2, 3, 4, 5. Okay, that's a little better. So all sides are the same. Hexagon would look like this, and so on. All sides are the same. These are all regular polygons. So if you have a regular polygon, you can find the measure of a single angle by dividing the sum of the interior angles by the number of sides. So we just use that same formula. So this is the same formula, and you just divide by n. So if you want to find the measure of each interior angle of a regular pentagon, you do s equals 5 minus 2 times 180, which is 3 minus 2, or sorry, 3 times 180, which is 540. Just divide by 5. Each angle is 108. An 18-gon, you just find the total angles in the numerator here using the formula from above. Divide by the number of angles, which is 18. Each angle is 160. All right, so last thing we're going to take notes on here, exterior angles of polygons. So a long time ago, we talked about exterior angles of triangles. So exterior angles are supplementary to their adjacent interior angle. Okay. So in a triangle here, we're making, we have 79, 61, and 40. Right here, we make a linear pair with 79. If they're supplementary, you do 180 minus 79, and you get 101. So that's where this came from. Over here, you make your exterior angle. It's a linear pair. So just side note, you make a linear pair. And then you do 180 minus 40, to get 140. And then same thing here, 180 minus 61 to get 119. If you add those up, 119 plus 101 plus 140, you get exterior angle measure of 360. You do the same thing over here. You make your linear pairs. 180 minus 124 is 56. 180 minus 76 is 104. 180 minus 89 is 91. And 180 minus 71 is 109. If you add up these four exterior angles, so 109 plus 56 plus 104 plus 91, you get 360 again. And you will see that the same thing is going to happen here. So we have a pentagon. You come up with all of your exterior angles by doing 180 minus the interior angle. That's where we got all of these from, 180 minus whatever the interior angle was. If you add all of these exterior angles up, you get 360 again. And you can see it works the same for this hexagon. So obviously we can conclude something about the exterior angles. You'll notice that the sum, no matter what the shape is, the sum is 360. So our conclusion about the sum of the exterior angles, the sum is 360. So let's work on some more examples here. So what is the measure of each exterior angle of a regular hexagon? So a regular hexagon has 6 sides. So we know that the exterior angles, their sum is 360. You take that and divide by 6. Each exterior angle has to be 60. So number 8, what is the measure of each exterior angle of a regular 24gon? So again, exterior angles, sum is always 360. If it's a 24gon, you have to divide by 24, and you get 15. If the exterior angle of a regular polygon measures 12, how many sides does the polygon have? So this time, we know that each exterior angle is 12. We don't know how many sides it has, but we do know that the sum has to be 360. So we're going to set it up the same way as this. This time we just don't know this number of sides. So 360 divided by x equals 12. We solve that by multiplying by x on both sides. And then they flipped the equation around. So we have 12x times 360, then divide by 12, x equals 30. And then this is the same type of question. If the exterior angle of a regular polygon measures 40, how many sides does the polygon have? So again, 360, we know that the sum of the exterior angles is 360. We don't know how many sides we have. So 360 divided by the number of sides has to equal 40. Again, multiply by x on both sides. These x's cancel out. 40x equals 360, divide by 40, and x equals 9. And that is it for 7.1 on interior and exterior angles of polygons.